Good morning, students. Today we will study about hyperconjugation. Hyperconjugation is one type of electronic effect. Under this heading, electronic effect, we had studied first type is inductive effect, second type is resonance effect, then third type is electromeric effect. Now the fourth type of electronic effect is a hyperconjugation. This hyperconjugation is a permanent electronic effect. So this do not depends upon the reagent and therefore it is a permanent. Then it explains the stability of carbocation, free radical and alkene. It is delocalization of sigma electrons of a CH bond of an alkyl group which is directly attached to the carbon atom and which is a part of unsaturated system or a system containing empty p orbital or the p orbital with unpaired electrons. So these are the different systems given here. Here it is a positively charged carbon that is called as a carbocation containing alpha carbon on which hydrogen is present called as a alpha hydrogen. So this is one type of system that shows hyperconjugation effect. Second type of system is this is unsaturated system containing carbon carbon double bond and this is bonded to carbon. That carbon is alpha carbon which is bonded to alpha hydrogen. So this is unsaturated system containing alpha carbon hydrogen sigma bond. Similarly, this is a free radical containing alpha carbon hydrogen sigma bond. So these are stabilized by using hyperconjugation effect. For understanding this hyperconjugation effect, we will consider this ethyl cation. Ethyl cation is CH3 CH2 plus charge. Here the positively charged carbon atom with empty p orbital has an adjacent methyl group and this contain alpha hydrogen. This alpha methyl group containing 3 alpha CH bonds. This alpha methyl group is in alignment with empty p orbital. The sigma electrons of CH bond are delocalized into empty p orbital and thereby stabilize the cation. This is given in this diagram. So see this structure of methyl group containing CH, CH and CH bond. One is below the plane, other is above the plane, and one more carbon hydrogen bond. It is in the plane. And here the sigma orbital is shown. One is having higher electron density one side and other side low electron density. Adjacent carbon is a CH2. This is CH3, CH2 positively charged. It is ethyl cation. Then here again one hydrogen, carbon hydrogen bond below the plane and one more carbon hydrogen bond. It is above the plane. Here the empty p orbital is shown and it is aligned with this carbon hydrogen sigma bond. So this effect is shown with the help of this dotted line. This is hyperconjugation effect. So hyperconjugation is thus a sigma pi conjugation. How it is take place? So one of the alpha hydrogen, these electrons are shifted with carbon carbon bond. That bond becomes double bond and this hydrogen in vicinity with the CH3 carbon, it is positively charged. this positive charge from the second carbon, it is transferred or shifted to this alpha hydrogen and it becomes H plus. So this is one hyperconjugation structure. This is structure number 1, then structure number 2. Then in the third structure, second alpha hydrogen participate in the formation of this hyperconjugation structure, and third one is third alpha carbon hydrogen bond that is shifted to the carbon carbon double bond and a positively charged hydrogen ion, it is in the vicinity of this. So the contributing structures are first, second, and second, third, and the fourth, involving delocalization of sigma electrons of the CH bond. The bond shows no covalent bond between the carbon and one alpha hydrogen. The hyperconjugation is therefore called as a no bond resonance. That is, there is a no bond between H plus ion and this methyl group containing carbon. So more number of such alpha hydrogen atoms, that is alpha carbon containing alpha hydrogen atoms, that shows the no bond resonance structure and that gives the more stability. The relative stability of carbocation therefore decreases in the order of tertiary carbocation is more stable than secondary than primary, because tertiary carbocation have this 9 alpha hydrogen atoms, that shows 9 hyperconjugation structure or no bond resonance structure. This is secondary carbocation that shows 6 hyperconjugation structure because 6 alpha hydrogen atom. Then ethyl carbocation is primary carbocation that shows 3 hyperconjugation structure or no bond resonance, and methyl group that do not show any hyperconjugation or no bond resonance structure. Therefore, stability is in the order tertiary carbocation, more stable than secondary, than primary, than methyl carbocation. Now let us look the propene that has a methyl group attached to carbon-carbon double bond. The delocalization of electrons by hyperconjugation in the propene can be depicted in the figure like this. So here there is a carbon-carbon double bond present in the propene. So that shifting of this alpha carbon hydrogen bond take place, that gives one resonance structure, no bond resonance structure. Similarly, here the two more resonance structures are possible, and this can be shown with the help of orbital diagram in the propene. This is alpha carbon hydrogen sigma bond, and these are the empty p orbitals present on the adjacent carbon atoms. Here the shifting or this electron pair shifting of alpha carbon hydrogen bond take place towards this empty p orbital in propene, and this is the orbital diagram of hyperconjugation in propene. Similar to this first hyperconjugation structure, the second is possible due to second alpha hydrogen atom. Third and fourth, that is also possible because of two more alpha hydrogen atoms present in the propene. So the effect of hyperconjugation is usually stronger than the inductive effect. And that is about this hyperconjugation effect, or that is also called as a no bond resonance effect. Thank you.